I once got cussed out by a Siemens certified instructor for what I'm about to teach you, but if you're struggling to understand ladder logic, then you just found the video you're looking for. Today we're going to learn about the 3 instructions that make up 80% of all programs. Our trainer is already wired per the Getting Started guide, and we're going to create a new project, and I'm going to call mine the Basic Bits. And then we're going to add device, controller, and I have an S7 1200 CPU, and it is a 1215 FC DC DC DC. And click OK. Then we're going to go into programming blocks and open up our main OB1. And if we go to our bit logic operators, we're going to be learning about this first one, second one, and this fourth one today. But first, we're going to go assign our tags. So we're going to open up our PLC tags, show all tags, and I am going to name my first one button 1. And as soon as I tab over, notice it automatically puts it as %I0.0, and that is the address of input 0. But now I'll go to button 2, button 3, button 4, switch 1, and then we're going to do light 1. And this is going to be an output. And in Siemens, outputs are Qs. And then we are going for address 0, bit 0. And I'll put light 2, light 3, light 4. And then we'll open our main back up. And we're going to bring down this first instruction right here. And we're going to hit our drop down and let's go find button 1. And then let's bring down this fourth instruction here and let's go find light 1. And then on our next network, we're going to bring down the second instruction, and this will be, again, button 1. And then we'll bring down this one, and it will be light 2. And now we're ready to, I almost made a mistake, guys. I forgot. We need to go to device configuration and click on these Ethernet ports here. And then in the bottom, we want to go to the Ethernet address. And you're going to set yours for 192.168.1 and then 10. Now I'm going to set mine at 35 because I'm at the training center and something's already on 10. And now we can download this program. And select PNIE for Ethernet. Start search, and yours by default is 192.168.110. Just select it and hit load. And let's hit the glasses here at the end. That's monitoring. We're going to turn monitoring on. If you put your program in right, your yellow light is on. You press your green button, your green light goes on, your yellow light goes off. Let's go back into our program and let's bring this column on out because you notice I didn't even call these instructions out. In fact, even on Monday with my students in our in-person training, I told them drag this shape down, drag this shape down. I don't ever talk about these words because here's where people get stumped. This first one, Siemens and many of them call a normally open contact. This is not a normally open contact. And what I love is if you just mouse over this a second, it says closed if value of queried operand equals 1. This is a go look for a 1. And if we mouse over the normally closed contact, it says closed if value queried equals a 0. And that's what this is. This is a go look for a 0. Now let's make sure we understand what I'm talking about here and why this is an issue. So first of all, input 0 is not illuminated right now. So it has a 0 in its box. I press the green button, it illuminates, and now it has a 1 in its box. So this instruction, according to Tim, is a go look for a 1, where at input 0. And since the green button's not pressed right now, it has a 0, which makes this false. And a false assignment instruction, as they call it, goes and writes a 0. And that will turn our green light off. This instruction goes and looks for a 0, and currently input 0 has a 0 in it, so it is true. And a true assignment instruction goes and writes a 1, and that is why our yellow light is on. So now I'm going to press the green button. This instruction goes and looks for a 1. Input 0 has a 1 in it, so it is true. And the true assignment instruction goes and writes a 1, and that's why our green light is now on. Now this instruction goes and looks for a 0. We're at input 0. Well, now it has a 1, so it's going to be false. And a false assignment instruction goes and writes a 0. Where to? Output 1, and that's why our yellow light is now off. Now, why is this so important, and why will I not get in line with the normally open and normally close? The issue is normally open and normally close, those are electrical contacts, and you're already having to learn that part and try to keep that straight. And now we're going to call these instructions normally open and normally close. So if I have a normally closed contact and I'm using a normally open instruction, when's it going to be true? And see, there's my issue is really it makes a stumbling block right away. And also instructors, and instructors especially, listen to me on this because I have too many students call me and say that their instructor has told them if they wire to a normally open contact, they have to use a normally open instruction. And it's simply not true. And that's why we want to make that distinction between these electrical terms and these programming terms. Now, if you will follow these 3 instructions and forget about saying normally open, when you see that normally open, say, go look for a 1. If I have a 1, it'll be true. If I have a 0, it'll be false. And when you see the normally closed, it's a go look for a 0. If it has a 0, it'll be true. If it has a 1, it'll be false. And then that assignment instruction, if it's true, it goes and writes a 1. If it's false, it goes and writes a 0. If you'll do that, you will understand ladder logic probably in the next 20 minutes of playing here. And once you've done that, click here to go learn about timers.